Okay, so in this video, we actually going to look at try to measure the resistance of two resistors using the resistor color coding. So one of these resistors is 10 ohms and the other is 220 ohms. Using the resistor color coding, let's determine which is which. I'm going to start with this resistor. So it's actually a 5-band code resistor. How do you know it's a 5-band code? Because you see it has five different color codings: 1, 2, 3, 4, and 5. So there's a 5-band code and there's a 4-band code. For this is a 5-band code. And to read the resistance of this resistor, we need to read the color codings on it. So what we can see is red, black, and brown. So let's go ahead and determine the resistance of this resistor: red, black, and brown. So we have red, black, and brown. On this table here, this table actually shows the various colors and their values. These are the values for the colors as a band. This is a value as a multiplier, and this is a value of the tolerance, the color as a tolerance. So the last color, as I said earlier, of a resistor, the last color, this brown, is always a tolerance. The second to the last is a multiplier, and every other color is a band or a digit on it. So let's go ahead and look for the resistance of this resistor. So we have a red on the table as digit is 2. So we have 2. We have another red, this is 2. We have a black, 0. And we have another black, and it's the second to the last color. As I said, every second to the last color is a multiplier. So we take this value times the value of this, that's 0. I mean that's, as a multiplier, it's 1. So we take this 220 ohms times 1, so it remains 220 ohms. And the tolerance actually of brown, and brown is plus or minus 1%. That's plus or minus 1%. So this is actually this resistor is actually a 220 ohms resistor with a tolerance of plus or minus 1%. So for the next, the color codings, we have brown, black, um, gold, and brown, black, gold, and brown. So brown, black, gold, and brown. So let's do the same thing. We have brown as the first color. Brown here is 1. We have black 0, black 0. We have gold, and gold is the second to the last color, and that's the multiplier. So gold here is 0.1. So we take this value, this entire value, times 0.1, so it gives us 10. And the last color, brown, is the tolerance, and brown here as a tolerance is 1. That is plus or minus 1%. So this is actually a 10 ohms resistor with a tolerance of plus or minus 1%. So what do we mean by tolerance? Tolerance is actually how precise or how accurate the resistor is. So it has an accuracy of plus or minus 1%. So this is how simple it is to use color coding to read a resistance of a resistor. And to test this out, we can actually use a multimeter to verify that our readings are correct. So I'm actually going to start with this. Okay, if I use a multimeter, as you can see, 11.4, that's approximately 10. Because when we apply this, you see that 11.4 is using the value of 10 kilo ohms. And if you measure the other resistor, let me try to adjust my multimeter so I could read the value. You will see that, okay, 218, so it falls within the range of 220 volt. So this is basically how simple it is to read a resistor using resistor color coding. And reading it through with a multimeter is quite easy when setting up your values. Here I have a digital multimeter, and if you want to read the color coding, you just have to switch your multimeter on and turn it to the resistor sections, where you have different values of resistance. We have ranging from the 200 ohms to 200 mega ohms resistor. So based on the resistance you are measuring, you look for a value closer to that resistance, and you just place your multimeter on the two terminals of your resistor, and it's quite easy to measure. So when I do this for this 218 ohms, so it's approximately 220 ohms. Okay, that's all for this video. See you next time. Thank you.